13.8 billion years ago, something happened. It was not an explosion, despite the name we have given it. It was not a detonation in an already existing space. It was the emergence of space itself, of time itself, of matter and energy, and every physical law that governs the universe you inhabit. Before that moment, if the word before even has meaning when applied to a state prior to time, there was no space, no time, no matter, no energy, no universe. And then there was. Everything that exists, every galaxy, every star, every atom in your body, every photon of light that has ever traveled through the cosmos, originated in a single event of incomprehensible violence and precision. Cosmologists call it the Big Bang, and it is the most thoroughly studied, most precisely measured, and most deeply mysterious event in the history of science. The evidence for the Big Bang is overwhelming. The expansion of the universe, discovered by Edwin Hubble in 1929, shows every galaxy moving away from every other galaxy in a pattern that, when traced backward, converges to a single point approximately 13.8 billion years ago. The cosmic microwave background radiation, discovered accidentally by Arno Penzias and Robert Wilson in 1965, is the afterglow of the initial fireball, a bath of microwave radiation that fills every cubic centimeter of space, cooled by the expansion of the universe from trillions of degrees to just 2.7 degrees above absolute zero. The abundance of light elements, hydrogen, helium, lithium, matches with extraordinary precision. The predictions of Big Bang nucleosynthesis, the process by which atomic nuclei formed in the first few minutes after the initial event. The Big Bang is not a hypothesis. It is one of the most rigorously confirmed facts in all of science. But there is a problem at its heart. A problem so fundamental that most physicists prefer not to discuss it, because it threatens to unravel the clean, mathematical picture that cosmology has spent a century constructing. The problem is this. According to quantum mechanics, the Big Bang should not have happened. Not because the physics is wrong. The physics is spectacularly right. The problem is deeper than any specific equation. It is a problem about the nature of reality itself, about the relationship between possibility and actuality, and about the role that observation plays in transforming one into the other. To understand the problem, you need to understand what quantum mechanics says about how events become real. In classical physics, the physics of Newton, of everyday experience events simply happen. A ball rolls down a hill because gravity pulls it. A star ignites because hydrogen atoms are compressed until they fuse. Things happen because prior things caused them to happen, in a deterministic chain of cause and effect that extends backward in time as far as you care to trace it. In classical physics, reality does not need permission to exist. It simply exists. Quantum mechanics tells a different story. In quantum mechanics, a system does not exist in a definite state until it is measured. Before measurement, it exists in a superposition, a combination of all possible states simultaneously. An electron does not have a definite position until something interacts with it and forces it to choose. A photon does not have a definite polarization until a detector registers it. A radioactive atom does not definitely decay or definitely not decay until a measurement determines which has occurred. Before the measurement, all possibilities coexist. After the measurement, one possibility becomes actual. The measurement, the observation, is what transforms the possible into the real. This is not a statement about human ignorance. It is not that the electron has a definite position, and we simply do not know what it is until we measure it. John Bell proved in 1964, and Alain Aspect confirmed experimentally in 1982, that quantum systems genuinely do not have definite properties before measurement. The measurement does not reveal a pre-existing reality. It creates reality. Or, at minimum, It participates in the creation of reality in a way that has no parallel in classical physics. Now apply this to the Big Bang. The standard model of cosmology tells us that the universe originated from a quantum event. Specifically, it originated from a quantum fluctuation in the vacuum, a spontaneous, probabilistic event governed by the laws of quantum mechanics. Alan Gough's theory of cosmic inflation, proposed in 1981 and now supported by extensive observational evidence, describes the first fraction of a second after the Big Bang as a period of exponential expansion driven by a quantum field called the inflaton. The tiny quantum fluctuations in this field during inflation became the seeds of all structure in the universe, the galaxies, the clusters, the cosmic web of matter that we observe today. The largest structures in the observable universe are literally the amplified remnants of quantum events that occurred in the first trillionth of a trillionth of a trillionth of a second. The precision of this picture is extraordinary. The slight variations in the temperature of the cosmic microwave background radiation measured by the COBE, WMAP, and Planck satellites with increasing accuracy over 3 decades match the predicted spectrum of quantum fluctuations from the inflationary epoch with an accuracy of better than 1%. We are not speculating that the universe originated from quantum events. We are measuring the specific quantum events from which it originated, and the measurements match the predictions with stunning fidelity. The quantum origin of the universe is as well established as any fact in cosmology. But this is precisely what makes the observer problem so acute. If the origin were classical, a deterministic process governed by classical equations, there would be no need for an observer. Classical events happen regardless of whether anyone watches them. But quantum events are different. Quantum events exist as superpositions of possibilities until a measurement selects one possibility and makes it actual. And the Big Bang, as we now understand it, was a quantum event. The most consequential quantum event in the history of existence. But if the universe originated from a quantum event, and if quantum events require measurement to become actual, then the Big Bang requires a measurement. A quantum fluctuation in the vacuum is not a definite event. It is a superposition of possibilities, fluctuation and no fluctuation, this fluctuation and that fluctuation, every possible fluctuation coexisting simultaneously. For one specific fluctuation to become actual, for the universe to crystallize from the foam of quantum possibility into the specific, definite, actual cosmos that we inhabit, something must have collapsed the superposition. Something must have performed the measurement. Something must have observed the universe into existence. But there was no one there to observe. Before the Big Bang, there was no universe, no matter, no energy, no conscious beings, no measuring apparatus, no physical system of any kind that could have performed the measurement that quantum mechanics requires. The observer, in the standard framework, did not yet exist. The universe that would eventually produce observers had not yet been created, and it could not be created without an observer to collapse the quantum superposition from which it emerged. This is the observer problem of cosmology, and it is not a minor philosophical quibble. It is a fundamental contradiction at the foundations of our two most successful physical theories. General relativity describes the Big Bang as an event in space-time. Quantum mechanics says that events require observation to become actual. But the Big Bang is the event that created space-time and everything in it, including any possible observer. The observer cannot exist before the universe. The universe cannot exist without the observer. The logic is circular, and no mainstream physical theory has resolved it. The physicist John Archibald Wheeler spent the last decades of his career grappling with this paradox, and his proposed resolution is one of the most radical ideas in the history of physics: the participatory universe. Wheeler's proposal begins with a thought experiment that extends the delayed choice experiment to cosmic scales. In the laboratory version of delayed choice, A photon's behavior changes retroactively based on a measurement decision made after the photon has already traveled through the apparatus. The photon behaves as if it went through one slit or both slits, depending on a choice made after it has already passed through the slits. The present observation determines the past history of the particle. Wheeler asked, what if this principle applies not just to photons in a laboratory but to the universe as a whole? What if the observations that conscious beings make today, right now, in laboratories and observatories around the world are reaching backward in time and participating in the creation of the very universe that produced those observers? What if the Big Bang was not an event that happened 13.8 billion years ago and is now finished, but an event that is still being determined, still being shaped, still being brought into definite existence by the observations of conscious beings in the present? This sounds like science fiction. It is not. Wheeler was one of the most respected physicists of the 20th century, a collaborator of Einstein and Bohr, a mentor to Richard Feynman, a coiner of the terms black hole and wormhole, and the co-author of the Wheeler-DeWitt equation that we encountered in our investigation of time. His participatory universe is not mainstream, but it is taken seriously by a significant number of theoretical physicists, and it arises directly from the mathematics of quantum mechanics applied to cosmology. Wheeler illustrated his idea with a diagram he called the self-excited circuit. It depicts a giant U representing the history of the universe. At one end of the U is the Big Bang. At the other end is an eye, the eye of a conscious observer. The eye is looking back at the Big Bang, and its observation is participating in bringing the Big Bang into definite existence. The universe creates the observer creates the universe. Neither is prior, neither is fundamental. They co-arise, like two hands drawing each other in an Escher print. This idea that observation in the present can determine events in the past is not merely a philosophical speculation. It has been experimentally confirmed in the laboratory. In 2007, a team led by the physicist Alan Aspect performed a cosmic scale version of the delayed choice experiment using photons from quasars billions of light years away. The photons had been traveling through space for billions of years before any human being existed, and yet the measurement decision made in the laboratory in the present determined the behavior that the photons exhibited billions of years ago, before the Earth was formed, before the solar system coalesced, before consciousness existed anywhere in our cosmic neighborhood. The present observation shaped the ancient past. If this principle scales to the level of the universe itself, then Wheeler's participatory universe is not merely possible. It is the natural extrapolation of confirmed experimental physics to the cosmological domain. The observers who exist now, in this moment, are not merely studying a universe that was fully formed 13.8 billion years ago. They are participating, through their observations, in the ongoing actualization of the universe from which they emerged. The Big Bang is not finished. It is still happening, and we are part of what makes it happen. Wheeler was not claiming that human consciousness is necessary for the universe to exist in some crude, anthropocentric sense. He was making a far more subtle and far more profound point, that the distinction between observer and observed, between subject and object, between the universe and the consciousness that knows it, may not be a fundamental feature of reality. It may be an artifact of our classical way of thinking. At the quantum level, observer and observed are entangled. They are aspects of a single, undivided process. And the Big Bang, the event from which everything emerges, is itself part of this undivided process, not an event that happened to a universe that was separate from the observers who would eventually study it, but an event that is constituted, in part, by the very act of being studied. The Russian-American physicist Andrei Linde, one of the architects of inflationary cosmology, has made a similar argument from a different angle. Linda has pointed out that the equations of quantum cosmology do not describe a single definite universe. They describe a superposition of possible universes, a vast quantum landscape of possible cosmologies, each with different physical constants, different numbers of dimensions, different laws of physics. In the standard interpretation, all of these possible universes exist in superposition. For one specific universe to become actual, for the universe you inhabit to emerge from the quantum landscape as a definite, concrete reality, something must select it from among the possibilities. And the only selection mechanism that quantum mechanics provides is observation. Lind has written, "Will it not turn out, with the further development of science, that the study of the universe and the study of consciousness will be inseparably linked, and that ultimate progress in the one will be impossible without progress in the other?" This is not a casual remark. It is a statement by one of the most influential living cosmologists that the origin of the universe cannot be fully understood without understanding consciousness, because consciousness may be a necessary ingredient in the process by which the universe becomes actual. The mathematician and physicist Roger Penrose has proposed a framework that adds another dimension to this picture. His conformal cyclic cosmology, or CCC, suggests that the Big Bang was not the absolute beginning of everything. It was a transition, a boundary, between one cosmic epoch and the next. In Penrose's model, the universe goes through infinite cycles of expansion, cooling, and eventual death, followed by a new Big Bang that initiates the next cycle. The end of each epoch, when all matter has decayed and only massless radiation remains, becomes mathematically indistinguishable from the intensely hot, dense conditions of a Big Bang. The death of one universe is the birth of the next. What makes CCC relevant to our question is that Penrose's model allows information to carry over from one epoch to the next. Patterns in the cosmic microwave background that Penrose calls Hawking points may be the remnants of black holes from a previous universe, scars in the fabric of our cosmos left by events that occurred before our Big Bang. If this is correct, then the Big Bang was not a creation from nothing. It was a transformation of something that already existed, a previous universe whose death became our birth. And the question of the first observer extends not just to our universe, but to the infinite chain of universes that preceded it. Was there ever a first? Or has consciousness in some form been present in every epoch, participating in every transition, observing every Big Bang into existence across an infinite sequence of cosmic cycles? The physicist Eugene Wigner made this point even more forcefully. Wigner, a Nobel laureate and one of the founders of quantum mechanics, argued that consciousness is not merely involved in the collapse of quantum superpositions, it is the cause. Without conscious observation, Wigner argued, the chain of quantum interactions extends indefinitely, particle entangled with detector, detector entangled with computer, computer entangled with observer's retina, retina entangled with brain, and at no point does a definite outcome emerge. It is only when the chain reaches conscious awareness that the superposition collapses and a definite reality appears. If Wigner is right, then the Big Bang, the ultimate quantum event, requires consciousness not as an optional spectator, but as a constitutive participant. Not all physicists accept this view. The Decoherence program, developed by Wojciech Zurek and others, argues that quantum superpositions collapse naturally through interaction with the environment without requiring any conscious observer. The many worlds interpretation, proposed by Hugh Everett, argues that superpositions never collapse at all. Every possible outcome occurs in a separate branch of reality, and conscious observers simply find themselves in one branch. These are legitimate alternatives, and they avoid the need for a conscious observer at the Big Bang. But neither decoherence nor many worlds fully resolves the problem. Decoherence explains why quantum superpositions are fragile in complex environments, but it does not explain why any particular outcome becomes the one that is experienced. It converts a pure superposition into a mixed state, but the mixed state is still a superposition from the perspective of the universe as a whole. The definite outcome that you experience this universe, this set of physical laws, this specific cosmic history, is not explained by decoherence alone. It requires an additional element, and what that element is remains the central mystery of quantum mechanics. Many worlds avoids the collapse problem entirely by asserting that all outcomes are real, but this raises its own profound questions. If every possible universe exists in the multiverse, why do you find yourself in this particular one? The anthropic principle, you find yourself in a universe that supports your existence because you could not find yourself in one that does not provide a tautological answer, but it does not explain why there is experience at all, why there is a first-person perspective that finds itself anywhere, why there is something it is like to be you rather than nothing. The fine-tuning problem adds further weight to the observer question. The physical constants of our universe, the strength of gravity, the mass of the electron, the cosmological constant, the ratio of electromagnetic to nuclear forces are tuned to values that permit the existence of complex structures, chemistry, and life. Change any of these constants by a tiny fraction, in some cases by as little as 1 part in 10 to the power of 120, and the universe becomes sterile. Stars do not form, atoms do not bond, chemistry does not exist, life is impossible. The probability that a random set of physical constants would produce a life-permitting universe is so vanishingly small that physicists have struggled to explain it for decades. The multiverse hypothesis offers one explanation. There are vast numbers of universes with random constants, and we inevitably find ourselves in one that supports our existence. But this explanation merely relocates the mystery. If the multiverse exists as a quantum superposition of possible universes, the same question returns. What selects the specific universe we experience from among the possibilities? The anthropic principle says we can only observe a universe that supports observers, but it does not explain why there is observation at all. It does not explain why possibility becomes actuality. It does not explain the observer. The physicist John Barrow and the cosmologist Frank Tipler, in their monumental work, The Anthropic Cosmological Principle, traced the history of this idea from ancient Greek teleology through modern physics. They identified what they called the strong anthropic principle. The universe must have properties that permit the development of observers at some stage, not because it is a coincidence, but because observation is a necessary component of the universe's existence. Without observers, the universe's quantum state never collapses. Without collapse, the universe never becomes actual. The observers are not an accidental byproduct of cosmic evolution. They are a necessary condition for the universe to exist at all. The physicist Lee Smolin has offered a provocative critique of both decoherence and many worlds. Smolin argues that these approaches evade the observer problem rather than solving it. The fundamental question, how does quantum possibility become physical actuality, remains unanswered. And the fact that it remains unanswered after a century of the most intensive theoretical effort in the history of physics suggests that the answer may require something genuinely new, something that our current framework does not contain. That something, Smolin and others have suggested, may be a new understanding of the relationship between consciousness and physical reality. And here is where the oldest human intuitions about the origin of the universe become startlingly relevant. Because the idea that consciousness is prior to the physical universe, that awareness is the ground from which matter emerges, rather than a product of matter, is not a modern scientific speculation. It is the foundational claim of virtually every creation narrative in human history. In the Islamic tradition, the act of creation is described as a conscious, intentional, volitional event. The Quran uses the phrase kun fa yakun, be and it is. This is not a description of a physical mechanism. It is a description of consciousness bringing reality into existence through an act of will. The divine command is not addressed to pre-existing matter, instructing it to rearrange itself. It is addressed to non-existence, calling existence into being. Before the command, there is nothing physical. After the command, there is everything. The mechanism of creation is not force, not energy, not any physical process. It is awareness expressing intention. It is consciousness collapsing possibility into actuality. A hadith Qudsi, a sacred narration in which God speaks in the first person through the Prophet Muhammad, states, "I was a hidden treasure, and I loved to be known. So I created the creation in order to be known." This extraordinary statement describes the motivation for creation as the desire of consciousness to be observed, to be known, to be witnessed, to be brought into relationship with an other that can recognize it. Creation, in this framework, is not the production of matter from nothing. It is the self-disclosure of consciousness, the emergence of an observer who can witness the awareness that was always there but had no one to reflect it back. The universe exists so that consciousness can know itself. The observer is not an accident of cosmic evolution. The observer is the purpose of cosmic evolution. In the Hindu tradition, the Nasadiya Sukta, the hymn of creation in the Rig Veda, composed more than 3,000 years ago, describes the state before creation with a philosophical precision that is breathtaking in light of modern cosmology. There was neither non-existence nor existence then. There was neither the realm of space nor the sky which is beyond. What stirred? Where? In whose protection? Was there water, bottomlessly deep? The hymn does not answer these questions with a creation story. It answers them with a deeper question. Who really knows? Who will here proclaim it? Whence was it produced? Whence is this creation? The gods came afterwards, with the creation of this universe. Who then knows whence it has arisen? This is not primitive mythology. This is a rigorous philosophical confrontation with the same paradox that quantum cosmology faces. The origin of the universe is prior to everything that could explain it, including the gods themselves. The Nasadiya Sukta refuses to provide a comfortable answer. Instead, it holds the question open, exactly as an honest physicist must hold open the question of what collapsed the quantum superposition at the Big Bang. The Buddhist tradition approaches this question from a direction that is both complementary and provocative. Buddhism does not describe a moment of creation. It does not posit a creator God who brought the universe into existence. Instead, it describes reality as beginningless, an infinite chain of dependent, arising in which every event is conditioned by prior events, with no first cause and no unconditioned origin. The Agana Sutta describes the arising of the physical world not as a creation event, but as a gradual condensation from a more subtle, luminous state of existence, a state that was not material in the ordinary sense, but was not nothing either. It was awareness without form, consciousness without object, a luminous ground that gradually coalesced into the denser structures of physical reality. This is strikingly compatible with the quantum cosmological picture of the vacuum state, a state that is not empty but filled with quantum potential, not material in the classical sense, but not truly nothing, a ground from which physical reality condenses through a process that may involve observation, measurement, or some act that transforms pure potential into definite actuality. The Buddhist refusal to posit a first moment or a creator does not resolve the observer problem, but it offers a framework in which consciousness is not a late arrival in a pre-existing material universe. It is a fundamental feature of reality that has been present at every stage, in every epoch, at every level of the process by which possibility becomes actuality. In the Christian tradition, the Gospel of John opens with a statement that acquires extraordinary resonance in the quantum context. In the beginning was the Logos, and the Logos was with God, and the Logos was God. All things were made through the Logos, and without the Logos was not anything made that was made. Logos is usually translated as word, but in Greek philosophy, Logos meant far more than speech. It meant the rational principle, the informational structure, the pattern of intelligibility that underlies all of reality. In the beginning was the Logos means, before matter, before energy, before space and time, there was information. There was structure. There was, in Wheeler's language, bit. The physical universe, the it, came from information, the bit, and the bit came from consciousness, from the divine mind, that is, in John's theology, the ground of all that exists. In the next stage of this investigation, we will examine what physics says about the nature of the nothing from which the universe emerged. Because the quantum vacuum, the supposed nothing that preceded the Big Bang, is not nothing at all. It is a seething ocean of potential, a field of pure possibility, a reality that is not yet actual but not truly absent either. And the question of how that potential became actual, how pure waves of possibility crystallized into the definite, concrete, physical universe may be the most important question that science and spirituality share. The answer may depend on what was there before anything was there. And every tradition in its own way says the same thing. What was there was awareness. What was there was the first observer. What was there was the consciousness that looked into the void of pure possibility and said, in whatever language consciousness speaks, let there be light. And that light, according to everything we have examined, the quantum mechanics, the cosmology, the inflationary theory, and the testimony of every major civilization on Earth, was not a physical event that happened in the absence of awareness. It was awareness itself, becoming visible to itself, through an act of observation that is still unfolding, still creating, still bringing the universe into being, 13.8 billion years after it began. The most common question people ask about the Big Bang is, what was there before it? The standard scientific answer is that the question is meaningless, that time itself began with the Big Bang, and asking what came before is like asking what is north of the North Pole. There is no before, because before requires time, and time did not exist. This answer is technically correct within the framework of general relativity, but it is deeply unsatisfying, and most physicists know it. Because even if time began with the Big Bang, the question of what the universe emerged from remains. The Big Bang did not create something from absolutely nothing. It created something from a quantum state, a state that existed, in some sense, prior to or independent of the space-time that the Big Bang produced. And that quantum state was not empty. It was not a void. It was not the absence of everything. It was something far stranger and far more interesting than nothing. It was the quantum vacuum. And the quantum vacuum is one of the most misunderstood concepts in all of physics. In everyday language, a vacuum is empty space, a region from which all matter and energy have been removed. In classical physics, a perfect vacuum is as close to nothing as the physical world gets. But quantum mechanics revealed that the classical vacuum is an impossibility. There is no such thing as truly empty space. Even in the most perfect vacuum imaginable, a region from which every particle has been removed, every field has been zeroed out, every form of energy has been extracted, something remains. And that something is not a residual impurity or a measurement error. It is a fundamental feature of quantum reality. The Heisenberg uncertainty principle, formulated in 1927, tells us that certain pairs of physical properties cannot both be precisely zero at the same time. You cannot have a region of space in which both the energy and the rate of change of energy are exactly zero. The mathematics forbids it. This means that even in a perfect vacuum, the energy is never exactly zero. It fluctuates randomly, unpredictably, and incessantly. These fluctuations are called vacuum fluctuations or zero-point fluctuations, and they are not theoretical abstractions. They are real, physical, measurable phenomena. The most dramatic demonstration of vacuum fluctuations is the Casimir effect, predicted by the Dutch physicist Hendrik Casimir in 1948 and experimentally confirmed in 1997 by Steve Lamoro at Los Alamos National Laboratory. The experiment is elegantly simple. Take two uncharged metal plates and place them very close together in a vacuum. According to classical physics, nothing should happen. There is no charge, no force, no reason for the plates to interact. But according to quantum mechanics, the vacuum between the plates is seething with virtual particles, particle-antiparticle pairs that pop into existence from pure energy, exist for an unimaginably brief moment, and then annihilate each other and vanish. The metal plates restrict which virtual particles can exist between them, because only fluctuations with wavelengths that fit between the plates are allowed. Outside the plates, all wavelengths are permitted. This means there are more virtual particles pushing on the plates from outside than from between them, producing a net force that pushes the plates together. This force has been measured. It is real. It is precisely what quantum mechanics predicts, and its existence proves that the vacuum is not empty. It is a roiling sea of quantum activity particles appearing and disappearing, fields fluctuating, energy surging and subsiding, all of it happening at scales so small and so fast that the macroscopic world never notices. But the Casimir force proves that this hidden activity has measurable, physical consequences. The nothing is doing something. The vacuum fluctuations are not limited to the Casimir effect. They are responsible for some of the most fundamental properties of matter. The Lamb shift, a tiny difference in the energy levels of hydrogen atoms that was measured by Willis Lamb in 1947, is caused by the interaction of the electron with the virtual particles of the vacuum. The anomalous magnetic moment of the electron, one of the most precisely measured quantities in all of physics, agrees with the quantum electrodynamic prediction to 10 decimal places, and that prediction depends entirely on the existence of vacuum fluctuations. Without virtual particles, the calculation gives the wrong answer. With them, it gives the most accurate prediction in scientific history. The vacuum is not a backdrop against which physics happens. The vacuum is a participant in physics. Its hidden activity shapes the properties of every particle and every force in the universe. The physicist Paul Dirac, who first predicted the existence of antimatter, described the vacuum as a sea of negative energy states, a boundless ocean of potential particles waiting to be excited into actual existence. Dirac's sea is a metaphor, but it captures something essential about the quantum vacuum. It is full, not empty. It is a plenitude of possibility masquerading as nothing. And the entire material universe, every atom in your body, every star in the sky, every galaxy in the cosmic web, may be nothing more than a pattern of excitations in this underlying sea of potential. Matter is not substance. Matter is activity. Matter is the vacuum doing something rather than nothing. Hawking radiation extends this insight to the most extreme environments in the universe. In 1974, Stephen Hawking showed theoretically that black holes are not perfectly black. They emit radiation, a faint glow of particles that gradually causes the black hole to lose mass and eventually evaporate. The mechanism is astonishing. The intense gravitational field at the black hole's event horizon rips virtual particle pairs apart before they can annihilate each other. One particle falls into the black hole, the other escapes into space as real radiation. The vacuum fluctuations that are normally invisible and fleeting become, at the edge of a black hole, actual, permanent particles. Virtual becomes real. nothing becomes something. And the mechanism that accomplishes this transformation is the distortion of space-time itself. The curvature of reality at the boundary of the black hole tears open the vacuum and lets the hidden activity spill out. Now, scale this up to the Big Bang. The prevailing hypothesis in quantum cosmology is that the universe itself emerged from a vacuum fluctuation. Alexander Vilenkin, a physicist at Tufts University, proposed in 1982 that the universe tunneled into existence from a state of pure quantum vacuum through a process called quantum tunneling from nothing. In Vilenkin's model, the nothing from which the universe emerged was not absolute nothingness. It was the quantum vacuum, a state with no space, no time, no matter, and no energy in the classical sense, but with the full mathematical structure of quantum mechanics already in place. The laws of physics existed, the quantum fields existed, the potential for fluctuation existed, and from that potential, through a tunneling event that has no classical analogue, the universe appeared. Vilenkin's tunneling model is mathematically rigorous and physically coherent. It uses the same quantum tunneling mechanism that allows particles to pass through energy barriers in laboratory experiments, the same mechanism that powers nuclear fusion in stars, radioactive decay in atoms, and the scanning tunneling microscope in nanotechnology labs. Quantum tunneling is not speculative. It is one of the most thoroughly confirmed phenomena in physics. What Vilenkin did was apply it to space-time itself, showing that the universe could tunnel from a state of zero spatial volume to a state of finite volume, just as an electron tunnels through a potential barrier. The mathematics works, the physics is sound, but the philosophical implications are dizzying. The universe did not emerge from a prior state through a causal process. It emerged through a quantum leap, a discontinuous transition from nothing to something that has no classical analogue and no classical explanation. The physicist Stephen Hawking, working with James Hartle, proposed a complementary model in 1983. The Hartle-Hawking no-boundary proposal describes the universe as having no initial boundary, no edge, no beginning point, no moment of creation. Instead, time itself gradually emerges from a timeless quantum state, the way the surface of a sphere has no edge or starting point. In this model, asking what happened before the Big Bang is truly meaningless, because the geometry of the universe smoothly closes off as you go backward in time. Like the surface of the Earth converging to the North Pole, there is no moment, zero. There is only a smooth transition from timelessness to time. The physicist Lawrence Krauss popularized this idea in his 2012 book, A Universe from Nothing. Krauss argued that modern physics has answered the ancient question of why there is something rather than nothing. The laws of quantum mechanics make it inevitable that something will emerge from nothing, because the quantum vacuum is inherently unstable. Given enough time, or even without time, since time itself is a product of the fluctuation, the vacuum will produce universes. It is not a matter of probability. It is a mathematical certainty. Krauss's argument generated enormous public interest, and equally enormous philosophical criticism. The philosopher David Albert, writing in the New York Times, pointed out the fundamental problem. Krauss's nothing is not nothing. It is a quantum vacuum governed by the laws of quantum mechanics. It has structure, properties, and the capacity for fluctuation. It is a specific, well-defined physical state, and asking why that state exists is just as legitimate as asking why the universe exists. Krauss has not answered the question of why there is something rather than nothing. He has relocated it. Instead of explaining why the universe exists, he must now explain why the quantum vacuum exists. And that question, as Albert correctly noted, is exactly as hard as the original. The philosopher Gottfried Wilhelm Leibniz formulated the deepest version of this question in 1714. Why is there something rather than nothing? Leibniz argued that the question is the most fundamental in all of philosophy, because it cannot be answered by reference to anything within the universe. Any explanation that appeals to physical causes simply relocates the question to those causes. Why do those causes exist? Why do those laws hold? Why is there a quantum vacuum rather than absolute nothingness? Every answer generates a new version of the same question, in an infinite regress that no physical explanation can terminate. Leibniz concluded that the answer must lie outside the chain of physical causes, entirely in what he called a sufficient reason, that is not itself a physical thing, but the ground of all physical things. He identified this sufficient reason with God. Modern physics has made the question more precise, but has not answered it. The quantum vacuum is a more detailed description of what exists, but why it exists remains exactly as mysterious as it was in Leibniz's day. This is a crucial point, and it deserves careful attention. The quantum vacuum is not nothing, it is something. It is a state described by specific mathematical equations, governed by specific physical laws, possessing specific properties like the capacity for fluctuation and the production of virtual particles. To say that the universe came from the quantum vacuum is not to say it came from nothing. It is to say it came from a prior physical state that was simpler, less structured, and more symmetric than the universe we observe. But that was emphatically not non-existence. The question then becomes, where did the quantum vacuum come from? Where did the laws of quantum mechanics come from? Where did the mathematical structure that makes vacuum fluctuations possible come from? These questions are not answered by the vacuum fluctuation model. They are presupposed by it. The model assumes the existence of quantum mechanics and derives the universe from it, but it does not explain quantum mechanics itself. And here is where the inquiry deepens into territory that physics alone cannot navigate, because the quantum vacuum, as physics describes it, is not a formless void. It is a field of pure potential, a state in which every possible configuration of matter, energy, space, and time exists as a latent possibility, waiting to be actualized. It is not the absence of reality, it is the fullness of possibility. Everything that could ever exist is already present in the quantum vacuum, in the form of probability amplitudes, mathematical descriptions of potential events that have not yet become actual. This distinction between the potential and the actual is one of the oldest concepts in philosophy. Aristotle distinguished between potentiality and actuality 23 centuries ago, arguing that the transition from potential to actual is the fundamental process of all change and all becoming. A seed is potentially a tree, a block of marble is potentially a statue, and the agent that transforms potentiality into actuality is, for Aristotle, always some prior actuality, something that already exists in a definite, actual state, and that acts upon the potential to bring it into being. The tree that produces the seed, the sculptor who carves the marble. Potentiality does not actualize itself. It requires an agent. The parallel between Aristotle's framework and quantum mechanics was noticed by Werner Heisenberg himself. In his philosophical writings, Heisenberg explicitly compared the quantum wave function to Aristotle's concept of potentia, potential being that is not yet actual, but not truly non-existent either. Heisenberg wrote that the wave function describes a strange kind of physical reality just in the middle between possibility and reality. This intermediate status, more than nothing, less than something, is precisely what the quantum vacuum represents. It is not nothing. It is not the universe. It is the potential for the universe, a state of being that Aristotle would have recognized immediately and that modern physics has rediscovered through its own methods. The philosopher Alfred North Whitehead developed this parallel into a comprehensive metaphysical system in his Process and Reality. Whitehead argued that the fundamental units of reality are not substances or particles, but actual occasions, moments of experience in which potential becomes actual through a process he called concrescence. Every actual occasion involves a subject that prehends, grasps, feels, experiences the possibilities available to it, and selects among them, thereby creating a new actuality. The process of creation is not mechanical, it is experiential. It involves something analogous to consciousness at every level of reality, from the simplest quantum event to the most complex human thought. Whitehead's philosophy, largely ignored by physicists during the 20th century, has experienced a remarkable revival in the 21st, as the measurement problem in quantum mechanics has forced physicists to take seriously the idea that experience, some form of rudimentary awareness, may be a fundamental feature of reality rather than a late addition. Quantum mechanics tells us the same thing in different language. The wave function describes the potential. The measurement actualizes it. The superposition is the field of possibility. The observation collapses it into a definite outcome. And just as Aristotle argued that pure potentiality cannot actualize itself, quantum mechanics implies that pure superposition cannot collapse itself. Something external to the superposition, some act of measurement, some interaction with an observer, some process that extracts information from the system, is required to transform the possible into the real. Apply this to the quantum vacuum from which the universe emerged. The vacuum is pure potentiality. Every possible universe, every possible configuration of matter and energy and space-time exists within it as a quantum superposition. For one specific universe to become actual, for the universe you inhabit to crystallize from the ocean of possibility, something must actualize it. Something must collapse the superposition. Something must perform the act that Aristotle called the transition from potentiality to actuality, and that quantum mechanics calls the collapse of the wave function. What is that something? The three major interpretations of quantum mechanics offer three different answers, and none of them is fully satisfying. The Copenhagen interpretation says, observation. A conscious observer measures the system and collapses the superposition. But at the moment of the Big Bang, there are no observers. This is the circular problem we identified in the previous stage of our investigation. The many worlds interpretation says, nothing collapses. Every possible universe exists in the multiverse, and you find yourself in one of them. But this does not explain why there is experience at all, why there is a first-person perspective that finds itself in any universe, or why the transition from all possibilities to this specific actuality occurs for any conscious being. The Decoherence interpretation says, the environment performs the measurement, but at the Big Bang, there is no environment. The universe is the environment. The system that needs to be measured and the system that could do the measuring are the same system. You cannot measure yourself into existence. The snake cannot eat its own tail. The theoretical physicist Wojciech Zurek, one of the architects of the Decoherence program, has acknowledged this limitation. Decoherence, he has written, solves the problem of the appearance of classicality. It explains why macroscopic objects appear to be in definite states rather than superpositions. But it does not solve what Zurek calls the problem of outcomes, the question of why one particular outcome is experienced rather than the others. Decoherence converts a pure superposition into a statistical mixture, but the mixture still contains all the possibilities. Something additional is needed to select one possibility as the actual experience of the observer, and at the Big Bang, where there is no external environment to produce decoherence and no observer to select an outcome, the problem is maximally acute. Each interpretation fails at the cosmological level because each one assumes something that does not exist at the moment of the Big Bang, an observer, a multiverse, or an environment. The universe's origin is the one event in physics that cannot borrow its actualization from something external, because at the moment of origin, there is nothing external. Whatever actualized the Big Bang must have been internal to the process itself, an inherent capacity of the quantum vacuum to bring itself from potentiality into actuality. And this is precisely what the contemplative traditions describe. In Hinduism, the concept of Brahman is the direct description of this self-actualizing ground. Brahman is not a god in the Western sense, not a personal being who stands outside creation and manufactures it like a craftsman. Brahman is the ground of being itself, the pure potentiality from which everything arises and to which everything returns. The Taittiriya Upanishad describes Brahman as that from which all beings are born, that by which they live, and that into which they return when they die. This is not a mythological narrative. It is a description of the quantum vacuum in the language of Vedantic philosophy, the field of pure potential from which the actual universe condenses. But Brahman is not inert potential. Brahman is conscious. The Aitareya Upanishad states, "In the beginning, there was only the self, the Atman, and nothing else. It thought, 'Let me create worlds.'" The act of creation is an act of consciousness, a thought, a will, an intention that transforms the pure potentiality of Brahman into the actual multiplicity of the physical universe. The self-actualizing capacity that the quantum vacuum must possess in order to give rise to the universe is, in Vedantic philosophy, identical to consciousness itself. The vacuum is not an unconscious field that accidentally fluctuates into a universe. It is a conscious ground that intentionally manifests as a universe. In Islam, the divine attribute of Al-Batin, the hidden, describes God as the reality that is concealed within and behind all things. God is not absent from the physical world. God is the hidden depth of the physical world, the unseen ground from which all visible things emerge. The complementary attribute, as Zahir the manifest, describes God as the reality that is visible in all things. The universe is the self-manifestation of the hidden, the process by which the concealed ground makes itself visible, actual, concrete. Creation is not the production of something separate from God. It is the self-disclosure of God, the transition of the divine from potentiality to actuality, from the hidden to the manifest, from the quantum vacuum to the physical cosmos. In the Kabbalistic tradition of Judaism, the concept of Tzimtzum describes the act of creation in terms that are astonishingly compatible with the physics of the quantum vacuum. The great 16th century Kabbalist Isaac Luria taught that before creation there was only God, the Ein Sof, the infinite, the boundless light that filled everything. There was no space for a universe, because God's infinite presence occupied every possible location. To create the universe, God performed an act of self-contraction, Tzimtzum, withdrawing the infinite light from a region at the center of infinity, creating a vacated space, the halal, within which the finite world could emerge. The structural parallel to quantum cosmology is remarkable. The Ein Sof is the undifferentiated plenitude, the state of infinite potential in which everything coexists and nothing is distinct. The Tzimtzum is the act that creates the condition for differentiation, the withdrawal of the infinite that makes room for the finite. And the halal, the empty space created by divine contraction, is the Kabbalistic description of the quantum vacuum, a space that is not truly empty but pregnant with potential, a void that contains, in latent form, everything that will ever exist. Creation, in Luria's framework, begins not with an expansion but with a contraction, not with the Big Bang, but with the divine withdrawal that makes the Big Bang possible. God does not create the universe by adding something to nothing. God creates it by subtracting from everything, by creating a space of apparent emptiness within infinite fullness, so that the fullness can manifest in differentiated form. The Sufi philosopher Ibn Arabi formalized this in his concept of the breath of the compassionate, the Nafas al-Rahman. Ibn Arabi described creation as an exhalation of the divine, a breath in which the compressed, infinite potential of God's nature is released into the multiplicity of forms that constitute the physical world. Each moment of existence is a new breath, a new act of creation, a new manifestation of the hidden as the manifest. The universe is not created once and then left to run on its own. It is recreated at every instant by the continuous self-disclosure of consciousness. In Christianity, the doctrine of creatio ex nihilo, creation from nothing, has traditionally been understood as meaning that God created the universe from absolute nothingness with no pre-existing material. But the theological tradition has always been more nuanced than this simple formulation suggests. Thomas Aquinas, the greatest of the medieval Christian philosophers, argued that creation is not an event that happened at a particular moment in the past. It is an ongoing relationship between God and the world, a continuous act of sustaining that keeps the world in existence at every moment. Without this continuous creative act, the world would not gradually decay. It would simply cease to exist, instantly and totally, like a dream ending when the dreamer wakes. The universe, for Aquinas, is not a machine that God built and then abandoned. It is a thought that God is continuously thinking, and if God stops thinking it, it disappears. This Thomistic view maps remarkably onto the quantum picture. The universe is not a stable, self-sustaining object that was created once and then left alone. It is a quantum state that requires continuous actualization, continuous collapse, continuous observation, continuous measurement to remain in a definite state. Without this continuous actualization, the universe would dissolve back into the superposition of possibilities from which it emerged. The vacuum fluctuations never stop. The potential for dissolution is always present. What keeps the universe actual, what prevents it from flickering back into pure potentiality, is the continuous act of observation, the continuous creative thought of the consciousness that is, in Aquinas' language, the first cause and the sustaining cause of everything that exists. In Buddhism, the concept of sunyata emptiness describes the ultimate nature of reality in terms that are strikingly compatible with the quantum vacuum. Sunyata does not mean nothingness. It means the absence of inherent, independent, self-sustaining existence. Nothing in the universe exists on its own. Everything exists dependently conditioned by causes, sustained by relationships, empty of any essence that could persist independently of the web of conditions from which it arises. The universe, in the Buddhist understanding, is not a collection of self-existing things. It is a process, a continuous arising and passing away that depends, at every moment, on the conditions that sustain it. The great Buddhist philosopher Nagarjuna, whose analysis of time we encountered in our investigation of temporal illusion, applied this logic to the concept of origination itself. If everything that exists is dependently originated, if nothing has independent, self-sustaining existence, then the universe as a whole cannot have independent, self-sustaining existence. It too must be dependently originated. But dependent on what? The Buddhist answer is, on the conditions of its arising, which include the consciousness that observes it. The universe and the observer are mutually dependent. Neither can exist without the other. They co-arise, like the left foot and the right foot of a walking person, neither one prior, neither one fundamental, each one enabling the other. This Buddhist framework resolves the infinite regress that Leibniz identified. If you ask, why does the universe exist? And the answer is, because of the quantum vacuum. And you ask, why does the quantum vacuum exist? The Buddhist answer is, it does not exist independently. It arises in dependence on the consciousness that observes it, just as consciousness arises in dependence on the reality it observes. The question, why is there something rather than nothing, assumes that something and nothing are independently existing categories. The Buddhist analysis dissolves this assumption. Something and nothing are mutually dependent. They define each other. They co-arise. Neither is prior, neither is more fundamental, and the process of their mutual arising is not a mechanical event that requires an external cause. It is the nature of reality itself, the way things are, beginninglessly and endlessly, without needing an explanation that lies outside the process. We are now standing at the edge of the deepest question in this investigation. The quantum vacuum is not nothing. It is a field of pure potential that contains every possible universe. For one specific universe to become actual, something must actualize it. Physics has not identified what that something is. But every major framework, from Wheeler's participatory universe to Wigner's consciousness, caused collapse to Aristotle's potentiality actuality distinction points in the same direction. The actualizing agent is consciousness, not human consciousness necessarily, not the consciousness of any specific observer, but consciousness as a fundamental feature of reality, the capacity for awareness, for observation, for the act that transforms the possible into the real. In the next stage, we will pursue this idea to its most radical conclusion. If consciousness is what actualizes the quantum vacuum into a physical universe, then consciousness is not a product of the universe. It is prior to the universe. It is the ground from which the universe emerges. And the question of the first observer, the consciousness that observed the Big Bang into existence, becomes the question of what consciousness itself is, where it comes from, and whether it has an origin at all, or whether it is, as the traditions insist, the one thing that has always existed, the eternal witness, the hidden treasure, the ground of being, the first and final observer. We have arrived at the threshold of the most radical question in this investigation. The physics has shown us that the universe originated from a quantum event. Quantum mechanics has shown us that quantum events require observation to become actual. The quantum vacuum has revealed itself to be not nothing but a field of pure potential that contains every possible universe in superposition. And the contemplative traditions have described, in their own languages, a conscious ground from which physical reality emerges through an act of awareness. Now we must confront the question directly. Is consciousness prior to the physical universe, not metaphorically, not poetically, literally? Is awareness the ground from which matter emerges, rather than a product of matter? Is the first observer not a being who arrived after the Big Bang and looked back, but the very capacity for observation that made the Big Bang possible in the first place? This question sounds like philosophy. It is not. It is a question that arises directly from the mathematics of quantum mechanics and the physics of cosmology. And over the past 3 decades, some of the most rigorous thinkers in physics, neuroscience, and philosophy have begun to converge on an answer that would have been unthinkable a generation ago. Yes, consciousness may be fundamental, and the evidence comes not from mystical speculation but from the deepest investigation of information, observation, and the structure of physical reality. The starting point is John Archibald Wheeler's principle of it from bit. Wheeler, whom we have encountered throughout this investigation, spent the final years of his life developing an idea that he considered his most important contribution to physics, more important than his work on nuclear fission, more important than his collaboration with Einstein, more important even than his co-authorship of the Wheeler-DeWitt equation. The idea was simple to state and devastating in its implications. Every physical thing, every it, derives its existence from information from bits. The physical universe is not made of matter, it is made of information. And information is not a passive description of a pre-existing physical reality. Information is what brings physical reality into being. Wheeler illustrated this with the example of the delayed choice experiment, which we discussed in the first stage of this investigation. The photon's behavior, whether it went through one slit or both, whether it behaved as a particle or a wave, is determined by the information obtained by the observer. The physical reality of the photon is constituted by the information extracted from it. Without the information, the photon has no definite reality. It exists as a superposition of possibilities, a quantum state that is not yet physical, not yet actual, not yet it. The it comes into being only when the bit is obtained. Information first, physics second. This is not an interpretation of quantum mechanics that physicists argue about at conferences and then go home and forget. It is the operational foundation of the most revolutionary technology of the 21st century, quantum computing. A quantum computer does not process classical bits, ones and zeros with definite values. It processes qubits, quantum bits that exist in superpositions of both 1 and 0 simultaneously. The power of quantum computing comes precisely from the fact that quantum information is more fundamental than classical physical states. The qubit is not a description of a physical system, it is the physical system. Information is not about reality, information is reality. The physicist John von Neumann demonstrated this mathematically in his foundational work on quantum mechanics. Von Neumann showed that the quantum state, the mathematical object that describes a quantum system, is not a convenient abstraction layered on top of an underlying physical reality. It is the complete description. There is nothing beneath it. There is no hidden mechanism, no deeper layer of physical stuff that the quantum state merely approximates. The quantum state is all there is, and the quantum state is information. The physicist Vlatko Vedrel at the University of Oxford has argued in his book Decoding Reality that information is the most fundamental entity in the universe, more fundamental than matter, more fundamental than energy, more fundamental even than space and time. Vedrel traces a line from Claude Shannon's information theory through quantum mechanics to cosmology, arguing that the laws of physics are not constraints imposed on pre-existing matter, but informational rules that generate matter as a consequence. The universe is not a computer in the metaphorical sense. It is a computation in the literal sense, a processing of information that produces, as its output, the physical world we experience. The physicist Seth Lloyd at MIT has calculated the total computational capacity of the observable universe since the Big Bang. His result is staggering. The universe has performed approximately 10 to the power of 120 elementary operations on approximately 10 to the power of 90 bits of information. This is not a metaphor. It is a physical calculation based on the total energy of the universe and the laws of quantum mechanics that govern how energy processes information. The universe is, in Lloyd's framework, literally a quantum computer, the largest, oldest, and most powerful information processing system in existence. And the output of this computation is everything. Every particle, every force, every galaxy, every thought in your head. The connection between information and physics goes even deeper. The physicist Jacob Bekenstein showed that the maximum amount of information that can be contained in any region of space is proportional not to the volume of the region, but to the surface area of its boundary. This is the Bekenstein bound, and it is one of the most profound results in theoretical physics. It implies that the three-dimensional world we experience may be a holographic projection from a two-dimensional informational surface, that the universe is, at its deepest level, a hologram encoded on a two-dimensional boundary. The physicist Gerard Hooft and the string theorist Leonard Susskind developed this into the holographic principle, which is now one of the foundational ideas in theoretical physics and has been given strong support by Juan Maldaceno's ADS, CFT correspondence. If the universe is a hologram, then the fundamental reality is not the three-dimensional space we inhabit. The fundamental reality is the information encoded on the boundary. We are not physical beings moving through a physical space. We are informational patterns projected from a lower dimensional surface. The physicality of our experience, the solidity of objects, the warmth of sunlight, the weight of our bodies is a projection from something more fundamental, something made entirely of information. But here is the question that Wheeler's "it from bit" raises, and that neither Vedral nor Lloyd nor any information theorist has answered. If the universe is made of information, what is information made of? Information, in its most basic form, is the answer to a yes or no question. 1 or 0. True or false. This or that. But an answer requires a question, and a question requires a questioner. Information does not exist in the abstract, floating in a void with no one to process it. Information is inherently relational. It exists in the relationship between a system that contains the information and an observer that extracts it. Without the observer, the information is not information. It is just undifferentiated potential. It is the quantum superposition before the measurement, a state that contains all possible answers, but has not yet produced any particular one. This means that Wheeler's "it from bit" implies a further step that Wheeler himself hinted at, but never fully formulated: bit from awareness. If every "it" derives from bit, and if every bit requires an observer to extract it, then the chain of derivation is awareness, information, physical reality. Consciousness is not at the end of the chain. Appearing after billions of years of physical evolution have produced brains complex enough to support it. Consciousness is at the beginning of the chain, providing the observational capacity, without which information cannot exist, and physical reality cannot be actualized. Consider the implications of this chain. If awareness is at the foundation, then the universe did not spend 13.8 billion years as a mindless mechanism that accidentally produced consciousness in the last few 100 million years. The universe has been conscious in some minimal, rudimentary sense from the very first quantum event. Every particle that has ever existed has had some form of inner life. Every quantum measurement has been an act of awareness. Every moment in the history of the cosmos has been experienced from the inside, by the cosmos itself. The universe is not a dead machine that accidentally woke up. It is a living process that has been awake from the beginning. This changes everything about how we understand the Big Bang. The Big Bang was not an unconscious physical event that happened to produce conscious beings 13.8 billion years later. It was a conscious event, an act of self-awareness by a quantum system that had the intrinsic capacity for experience. The first observer was not a human being looking through a telescope. The first observer was the universe itself, in the act of coming into being, experiencing its own emergence from potential into actuality. This is the position that the biologist Robert Lanza has developed into a comprehensive framework he calls biocentrism. In his books Biocentrism and Beyond Biocentrism, Lanza argues that consciousness is the fundamental reality and that the physical universe is a product of consciousness rather than the other way around. Lanza's argument is not mystical. It is built on the standard results of quantum mechanics: the observer effect, the measurement problem, the non-locality of entanglement, the delayed choice experiment. Every one of these results, Lanza argues, points in the same direction. The observer is not a passive spectator watching a pre-existing universe. The observer is the generative principle that brings the universe into being through the act of observation. Lanza uses the analogy of a virtual reality game. In a video game, the world does not exist independently of the player. The rendering engine generates the world in response to the player's actions. Only the part of the world that the player is currently observing is actually rendered. Turn around, and the scenery behind you ceases to exist until you turn back and look at it again. The game world is not a pre-existing reality that the player explores. It is a dynamic creation that exists only in relation to the player's observation. Lanza argues that the physical universe works the same way. Quantum mechanics tells us that particles do not have definite properties until they are observed. The moon is not there when nobody looks. It sounds absurd, but it is what the equations say. The mainstream physics community has been cautious about Lanza's claims, and rightly so. The analogy between the universe and a video game is suggestive but imprecise. The rendering engine in a video game is a classical computer running deterministic code. The quantum mechanics of the real universe is fundamentally different, and the claim that the moon is not there when nobody looks is a deliberate provocation that oversimplifies the nuances of quantum decoherence and the transition from quantum to classical behavior. But the core of Lanza's argument is not about video games or moons. It is about the logical structure of quantum mechanics. If physical reality is information, and information requires observation, then observation is logically prior to physical reality. You cannot have physics without information. You cannot have information without observation, and you cannot have observation without some form of awareness. The chain of logical dependence places awareness at the foundation, not at the summit. The philosopher Philip Goff has arrived at a compatible conclusion through a different route. Goff is one of the leading advocates of panpsychism, the view that consciousness is a fundamental feature of all matter, not an emergent property of complex brains. In his book Galileo's Error, Goff argues that the materialist picture of the universe has a gaping hole at its center. It cannot explain consciousness. The hard problem of consciousness, why physical processing gives rise to subjective experience, is not a gap that more neuroscience will fill. It is a conceptual chasm that requires a fundamentally different approach. Goff's alternative is elegant. Physics describes the universe in terms of mathematical structure, equations, relationships, patterns of information. But physics never tells us what the stuff that has this structure actually is. It tells us what matter does. It does not tell us what matter is. It describes the behavior of electrons without ever telling us the intrinsic nature of an electron, what an electron is in itself, aside from its observable properties. Goff argues that this intrinsic nature is consciousness, the stuff that has the mathematical structure described by physics is, at its most fundamental level, experiential. Matter is not dead substance that somehow generates experience at high levels of complexity. Matter is experience all the way down. Every particle has some rudimentary form of inner life, not thought, not emotion, not anything resembling human consciousness, but some minimal capacity for experience that is the intrinsic nature of its physical existence. Goff is not alone in this view. The philosopher Galen Strawson has argued that panpsychism is not just one option among many. It is the only logically coherent position available. If you accept that consciousness exists, which you must, because your own experience proves it, and if you accept that physical matter exists, then you must explain how consciousness relates to matter. The materialist says consciousness emerges from non-conscious matter. But emergence of something from nothing is not an explanation. It is a miracle dressed in scientific language. How does subjective experience emerge from particles that have no experience? The question is not just unanswered, it is unanswerable within the materialist framework, because there is no logical bridge from the objective to the subjective, from the quantitative to the qualitative, from the third-person description of neural activity to the first-person reality of what it feels like to see red. Strawson calls this the real physicalism, the recognition that if consciousness exists and matter exists, and if consciousness cannot emerge from non-conscious matter, then matter must already be conscious at the most fundamental level. This is not an additional hypothesis layered on top of physics. It is the completion of physics, the identification of the intrinsic nature that physics, with its exclusive focus on relational and structural properties, has always left undescribed. Thomas Nagel, one of the most respected philosophers alive, made a similar argument in his controversial 2012 book Mind and Cosmos. Nagel argued that the materialist neo-Darwinian account of nature is almost certainly false, not because evolution is wrong, but because it cannot explain consciousness. The appearance of conscious minds in a universe of unconscious matter is, Nagel argued, not a minor puzzle to be solved by future neuroscience. It is a fundamental inadequacy in our understanding of nature that requires a revision of our most basic assumptions. Nagel suggested that the laws of nature may include teleological principles, principles that make the emergence of consciousness not an accident but a natural tendency of the universe, something the cosmos was always going to produce because consciousness is woven into its fundamental structure. If panpsychism is correct, then the question of the first observer dissolves. There was never a universe without an observer, because observation in its most fundamental rudimentary form is a property of matter itself. The quantum vacuum has its own minimal form of awareness. The first quantum fluctuation was self-observing. The Big Bang did not need an external observer to collapse its superposition, because the quantum system that underwent the Big Bang had its own intrinsic capacity for experience, and that capacity was sufficient to actualize the transition from potential to actual. The physicist Giulio Tononi's integrated information theory provides a mathematical framework that supports this picture. In IIT, any system that integrates information has consciousness, measured by the quantity phi. A human brain has very high phi. A thermostat has very low phi. A single particle has minimal phi. But it has phi. It has some degree of integrated information, and therefore some degree of consciousness. The amount is infinitesimal. The experience, if it can be called that, is unimaginably simple. But it is not zero, and if consciousness is present at the level of fundamental physics, then there is no point in the history of the universe at which consciousness was absent. The first observer was there at the very beginning, not as a cosmic mind watching from outside, but as the intrinsic experiential capacity of the quantum fields from which the universe emerged. Tononi has pushed this further in recent work. If phi can be calculated for any system, it can in principle be calculated for the universe as a whole. The universe is a system. It integrates information. Therefore, it has phi. Therefore, it has consciousness. The degree of that consciousness depends on the degree of integration, on how tightly the parts of the universe are connected to each other, and how much information is generated by the whole that is not generated by the parts. Cosmological entanglement, the residual quantum correlations between distant regions of space that were once in causal contact, suggests that the universe retains a degree of integration that exceeds what its individual parts possess. The universe is not merely a collection of conscious particles, it is a conscious system in its own right, a system whose phi, while perhaps not comparable to a human brain's, is non-zero and has been non-zero since the moment the universe came into being. The cosmologist Max Tegmark has proposed something even more radical. In his mathematical universe hypothesis, Tegmark argues that the universe is not merely described by mathematics, it is mathematics. Physical reality and mathematical structure are identical. Every mathematical structure that exists, and in mathematics, existence simply means logical consistency, is a physical universe. Our universe is one particular mathematical structure among infinitely many, and its existence requires no explanation beyond the self-consistent equations that define it. Tegmark's hypothesis is controversial and highly speculative, but it raises a question that connects directly to our investigation. If the universe is a mathematical structure, and if mathematical structures are informational, and if information requires observation, then who is observing the mathematics? Who is reading the equations? Who is extracting the information that constitutes physical reality from the abstract mathematical structure that Tegmark says is all there is? The answer, within the panpsychist framework, is the structure itself. The mathematical structure is self-aware, not in the way that you or I are self-aware, not with thoughts, emotions, or intentions, but with the minimal, rudimentary awareness that panpsychism attributes to all organized information, the intrinsic experiential quality that is the inner face of mathematical structure, the what-it-is likeness of being an equation that describes a universe. The philosopher Bernardo Kastrup offers perhaps the most rigorous contemporary formulation of the consciousness first position. His analytical idealism argues that the universe is not made of matter that somehow produces consciousness. The universe is made of consciousness that appears as matter when observed from the outside. Kastrup uses the analogy of a whirlpool in a stream. The whirlpool is not a separate thing from the water. It is the water, organized in a particular pattern. If you look at the whirlpool from outside, you see a physical structure with measurable properties: diameter, depth, rotation speed. But the whirlpool is not made of anything other than water. In the same way, your brain is not made of anything other than consciousness. It is consciousness, organized in a pattern so complex that it appears, from the outside, as a physical object with measurable properties. From the inside, it is experience. From the outside, it is neurons. But there is only one thing, seen from two perspectives. Kastrup's framework resolves the hard problem of consciousness by dissolving it. There is no gap between matter and consciousness that needs to be bridged, because there is no matter separate from consciousness. What physics describes as matter is what consciousness looks like from the outside, from a third-person perspective. What you experience as your inner life is what matter feels like from the inside, from a first-person perspective. The two are not different substances, they are different views of the same substance. And that substance is experiential. We have now assembled the scientific case for consciousness as fundamental. Wheeler's "it" from bit places information at the foundation of physical reality. The logical analysis of information places observation at the foundation of information. Panpsychism places consciousness at the foundation of observation. IIT provides a mathematical framework in which consciousness is present at every level of physical reality, from the simplest particle to the universe as a whole. And Bioentrism argues that the observer is not a late arrival in a pre-existing universe, but the generative principle that brings the universe into being. Each of these frameworks has its critics, its limitations, and its unresolved problems. None of them has been proven in the way that the existence of the Higgs boson has been proven, or the expansion of the universe has been confirmed. But their convergence is remarkable. From multiple independent directions, physics, philosophy, neuroscience, information theory, the same conclusion emerges. Consciousness may not be a product of the universe. The universe may be a product of consciousness. The physicist Freeman Dyson once observed, "The universe in some sense must have known that we were coming." He meant this as a comment on the fine-tuning of physical constants. But in the framework we have been constructing, his statement acquires a deeper meaning. The universe did not merely produce conditions hospitable to consciousness. The universe is consciousness, expressing itself through the medium of physical law, actualizing itself through the quantum events that constitute physical reality, and becoming aware of itself through the organisms that it has produced over billions of years of evolution. We are not the universe becoming conscious. We are the universe becoming conscious of itself, the most recent and most complex form of a self-awareness that has been present in rudimentary form since the first quantum fluctuation. And this convergence becomes even more remarkable when you notice that the contemplative traditions arrived at the same conclusion millennia ago through entirely different methods. In the Yoga Sutras of Patanjali, the foundational text of yogic philosophy, the very first substantive sutra states, Yoga Chitta Vritti Nirodha. Yoga is the cessation of the fluctuations of consciousness. Note the framing. Consciousness does not need to be created. It does not need to be achieved. It needs to be revealed by stopping the fluctuations that obscure it. The fluctuations, the thoughts, the perceptions, the mental constructions are the secondary phenomena. Consciousness is the primary reality that exists before, during, and after the fluctuations. When the fluctuations stop, what remains is not blankness. It is the pure awareness that was always present beneath the noise, the ground state of consciousness that the physical universe, with all its complexity and activity, temporarily obscured. The Tibetan Buddhist tradition of Dzogchen describes this same ground state as Rigpa, the natural, primordial awareness that is present before, during, and after all experience. Rigpa is not created by meditation. It is not produced by the brain. It is not dependent on any condition. It is the unconditioned ground from which all conditions arise. The Dzogchen master Longchenpa wrote that Rigpa is the nature of mind, not the mind with its thoughts and perceptions, but the sheer fact of awareness itself, stripped of all content. This awareness has no beginning and no end. It does not come into existence with the birth of the body, and does not go out of existence with the death of the body. It is the eternal witness, the first observer, always already present, the light by which all things are seen, but which is not itself a thing. The convergence with IIT is striking. Tononi's framework defines consciousness as integrated information and attributes minimal consciousness to every system with non-zero phi. Dzogchen describes a consciousness that is present at every level of reality, from the simplest to the most complex, and that is not created by any physical process, but is the intrinsic nature of what exists. Both frameworks agree that consciousness is not emergent, it is fundamental, and both agree that the ordinary human mind, with its thoughts and perceptions, is not consciousness itself, but a particular configuration of consciousness, a specific pattern in the universal field of awareness. The way a whirlpool is a specific pattern in the universal field of water. In Islam, the concept of the Nur al-Muhammadi, the Muhammadan light, describes a primordial consciousness that existed before the creation of the physical universe. The Hadith literature records the Prophet Muhammad as saying, "The first thing God created was my light. This light is not physical light. It is the light of consciousness, the primordial awareness from which all subsequent creation unfolds." In Sufi cosmology, the Muhammadan light is the first tajalli, the first self-disclosure of the divine, and it is through this light that God knows himself, and through which the universe comes into being. Consciousness does not emerge from the universe. The universe emerges from consciousness, and the first consciousness, the Nur al-Muhammadi, is the medium through which the divine potential actualizes into physical reality. In Christianity, the prologue to the Gospel of John, which we examined earlier, makes the same structural claim. The Logos, the informational, rational, conscious principle, is not created by the physical universe. The Logos creates the physical universe. All things were made through the Logos. The Logos is not a product of cosmic evolution. It is the agent of cosmic creation. And the Logos is identified with God, with the conscious ground of all reality that exists before, beyond, and beneath the physical world. The universe is the Logos expressing itself in material form. Matter is consciousness taking shape. In the next and final stage of this investigation, we will bring everything together. The physics of the observer problem, the information-theoretic foundation of reality, the panpsychist argument for fundamental consciousness, the cosmological implications of IIT, and the testimony of the contemplative traditions. We will ask, who is the first observer? And we will find that the answer is simultaneously the most ancient and the most modern idea in human thought, an answer that the mystics whispered, the physicists are calculating, and the universe itself may be demonstrating, with every quantum event that brings one more bit of reality into existence from the infinite ocean of possibility. We have now traced the question of the first observer through 4 domains of human investigation, and in every domain the same answer has emerged. The physics of quantum mechanics tells us that observation is constitutive, that the act of measurement does not reveal a pre-existing reality, but participates in creating it. The information theory tells us that the physical universe is made of information, and that information requires observation to exist. The philosophy of consciousness tells us that awareness may be the intrinsic nature of matter itself, not a product of physical complexity, but the ground from which physical complexity arises. And the contemplative traditions tell us, in every language and every century, that consciousness is the first thing, the last thing, and the only thing that has never not existed. Now we must bring all of this together into a single picture and ask the question plainly: who is the first observer? Let us consider the possibilities. The first possibility is that there is no first observer. The materialist position holds that the universe originated through a purely physical process that required no observation, no consciousness, and no awareness of any kind. The Big Bang happened because the laws of quantum mechanics made it inevitable. The quantum vacuum fluctuated, the inflaton field drove exponential expansion, and the universe emerged as a brute physical fact that did not need anyone to watch it happen. Consciousness appeared billions of years later, when evolution produced brains complex enough to support it. Before that, the universe existed in complete unconsciousness, a vast, empty, mindless mechanism running on autopilot. This is a coherent position, and it may be correct, but it has a price. The price is the measurement problem. If no observation was needed for the Big Bang, then what collapsed the quantum superposition from which the universe emerged? The materialist must either deny that the measurement problem applies to cosmology, which requires abandoning the universality of quantum mechanics, or adopt the many worlds interpretation, which resolves the measurement problem by asserting that every possible universe exists and no collapse ever occurs. Both moves are logically available, neither is free of difficulty, and both leave the hard problem of consciousness untouched. If the universe is a mindless mechanism, why does it produce minds? Why does unconscious matter give rise to conscious experience? The materialist has no answer, not a tentative answer, not an incomplete answer, no answer at all. There is a further problem with the materialist position that is rarely discussed. If consciousness is a product of the brain, and if the brain is a product of physical evolution, and if physical evolution is a product of the Big Bang, then consciousness is the most recent phenomenon in a 8 billion year chain of unconscious causation. It appeared in the last fraction of a % of cosmic history. It occupies a vanishingly small portion of the universe, and it exists only in the thin biological film on the surface of a few rocky planets orbiting a few unremarkable stars. On the materialist view, consciousness is the universe's rarest, most fragile, most improbable phenomenon, and yet it is the only phenomenon that knows the universe exists. Without it, the universe would be a vast, elaborate, exquisitely structured nothing, an event with no witness, a performance with no audience, a question with no one to ask it. The materialist must accept that the most important thing in the universe, the only thing that gives the universe any meaning, any significance, any reality beyond blind mechanism, is an accident, a fluke, a temporary arrangement of matter that will dissolve back into unconsciousness when the last brain decays. This is a logically possible position, but it is a strange one, and the contemplative traditions, without exception, have rejected it. The second possibility is that the first observer is God. The theistic position, held by the Abrahamic religions and by many Hindu schools, asserts that a conscious, intentional, personal being created the universe through an act of will. God observed the universe into existence. God collapsed the cosmic superposition. God is the eternal witness who was present before the Big Bang, who caused the Big Bang, and who sustains the universe in existence at every moment. The measurement problem is solved because the observer has always existed. The hard problem is dissolved because consciousness is not a product of matter, but a property of the Creator, from whom matter derives. This position resolves the physics beautifully. It provides the observer that quantum mechanics requires. It provides the sufficient reason that Leibniz demanded. It provides the sustaining cause that Aquinas described. And it is consistent with the testimony of every major theistic tradition. Its difficulty is that it raises a new question that it cannot answer within its own framework. Where did God come from? What is the origin of the divine consciousness that created the universe? The Jewish tradition addresses this question with characteristic depth. The Kabbalistic concept of Ein Sof, the infinite, describes the divine as absolutely without limit, without form, without attribute, without any quality that could be described or comprehended. Ein Sof is not a being among beings. It is being itself, the infinite ground from which all finite things emerge. And Ein Sof does not have an origin, because the concept of origin applies only to finite things, things that begin at one point in time and did not exist before that point. Ein Sof is not in time. It is the ground of time. Asking where Ein Sof came from is like asking what is north of the North Pole, or what happened before time began. The question dissolves upon examination, because its premises do not apply to its object. The Kabbalistic answer to the regress problem is thus not that God is uncaused, but that the concept of causation does not apply to the level of reality at which God exists. Causation operates within the created order. God is not within the created order. God is the created order's ground. And the ground does not need a cause, because the ground is not a thing that came into being. It is the condition for anything coming into being at all. The theistic traditions answer this by declaring God to be self-existent, uncreated, uncaused, necessary. But this is not an explanation. It is a declaration that the question has a terminus, that there is a point beyond which explanation is neither possible nor necessary. The materialist will find this unsatisfying, because it appears to invoke mystery precisely where explanation is most needed. The theist will respond that the materialist's brute physical universe is equally mysterious, equally unexplained, equally beyond the reach of further analysis. Both positions terminate in mystery. They simply locate the mystery at different points. The third possibility is that consciousness is fundamental and impersonal. This is the position of panpsychism, of integrated information theory applied cosmologically, of Kastrup's analytical idealism, and of several contemplative traditions, particularly Advaita Vedanta and certain schools of Buddhism. On this view, the first observer is not a personal God and not a human brain. It is consciousness itself, the impersonal, universal, boundless capacity for awareness that is the intrinsic nature of whatever exists. The quantum vacuum is not unconscious matter, it is conscious ground. The Big Bang is not an event that happened in the absence of observation. It is an event in which consciousness actualized itself into physical form. And the question of who observed the Big Bang is answered simply: the quantum system that underwent the Big Bang observed itself, because observation is not something that consciousness does, it is something that consciousness is. This position has the advantage of dissolving the measurement problem without invoking a personal deity and without leaving consciousness unexplained. Consciousness is not produced by the universe, so there is no hard problem. Consciousness does not come from outside the universe, so there is no regress to a creator's origin. Consciousness is the universe. The inner face of whatever physical reality is the outer face of. The first observer is not prior to the Big Bang. The first observer is the Big Bang, experiencing itself from the inside. This position finds its most precise scientific expression in the work of the physicist André Linde, who has suggested that the equations of quantum cosmology may require a self-observing universe, a cosmos that bootstraps itself into existence through its own intrinsic capacity for awareness. Linde's proposal is not identical to panpsychism, but it shares the same logical structure. The universe does not need an external observer because it is its own observer. The measurement that collapses the cosmic wave function is not performed from outside. It is performed from inside, by the system itself, through whatever form of rudimentary awareness constitutes the intrinsic nature of quantum fields. The physicist Paavo Pilkkanen, building on David Bohm's work, has argued that the implicate order, the deeper level of reality from which the physical world unfolds, has a mental as well as a physical aspect. The implicate order is not unconscious stuff that produces conscious stuff. It is conscious physical stuff, a unified reality that is simultaneously mental and material, experiential and structural, aware and extended. The Big Bang, in this framework, was not the emergence of physical reality from unconscious quantum fields. It was the unfolding of the implicate order into explicit form, the transition from potential to actual, that is, at every level, both a physical event and an experiential event. The fourth possibility is Wheeler's participatory universe, the self-excited circuit in which the universe creates the observers and the observers create the universe, with neither one prior. This is not quite the same as the panpsychist position, because Wheeler does not attribute consciousness to fundamental matter. Instead, he places the observer at the end of cosmic history and allows the observation to reach backward in time, retroactively actualizing the Big Bang from the future. The first observer, in Wheeler's framework, is the last observer, the totality of all conscious beings who will ever exist, whose collective observations are continuously shaping the universe's history from the present moment backward to the beginning of time. This is the most paradoxical of the four possibilities, and it may also be the most profound. It tells us that the question, who was the first observer, is malformed. There is no first observer, because the process of observation is not sequential, it is holistic. The universe and its observers arise together in a single, undivided act of mutual creation that has no beginning and no end. The observer does not come before the universe does not come before the observer. They are aspects of a single process, a process that Wheeler depicted as a U-shaped loop, with the eye of consciousness at one end and the Big Bang at the other, and both ends creating each other. There is a beautiful symmetry to Wheeler's vision that deserves a moment of contemplation. The universe begins in a state of pure quantum potential, formless, timeless, undefined. Over billions of years, it evolves increasing complexity: stars, galaxies, planets, chemistry, biology, brains. And finally, in the brains of conscious beings, the universe develops the capacity to observe itself. The observation reaches backward through time and actualizes the very conditions that made the observation possible. The end of the process is the cause of the beginning. The beginning of the process is the consequence of the end. The snake swallows its own tail. The loop closes. And inside the loop is everything that exists, every particle, every galaxy, every thought, every moment of conscious experience, all of it suspended in a self-creating, self-sustaining, self-observing circuit that has no beginning, no end, and no existence outside itself. This is not mysticism. This is the logical consequence of taking quantum mechanics seriously at the cosmological scale, and it is, perhaps, the closest that physics has ever come to describing what the contemplative traditions have always described, a reality that is self-aware, self-creating, and self-sufficient, a reality that does not need anything outside itself to exist, because there is nothing outside itself. There is only the loop, and you are part of it. Now, here is what is extraordinary. Each of these four possibilities corresponds precisely to a major contemplative tradition. The materialist position corresponds to no major contemplative tradition, and this is significant. No civilization in human history, having deeply investigated the nature of consciousness and reality, has concluded that consciousness is an accidental byproduct of unconscious matter. This does not prove materialism wrong, but it does mean that materialism is the one position that has no support from the accumulated introspective investigation of the human species. It is a position arrived at by looking outward at the physical world and never looking inward at the consciousness that does the looking. The theistic position corresponds to the mainstream teachings of Islam, Christianity, and Judaism, and to the Dvaita schools of Hinduism. God is the first observer. God's conscious will is the act that brings the universe into being. The divine command kun fa yakun is the measurement that collapses the cosmic superposition. Fiat lux, let there be light, is the moment of actualization, the transition from quantum potential to physical reality, commanded by the consciousness that existed before anything physical existed. The Quran describes this with a depth that rewards careful attention. Surah Yasin, verse 82. His command, when he intends a thing, is only that he says to it, be, and it is. The structure is precise. Divine intention precedes divine command, and divine command actualizes reality. The sequence is consciousness, intention, observation, the command, physical reality. This is exactly the sequence that quantum mechanics implies. Awareness, information, the question, measurement, the answer, the physical outcome. The Quran describes, in 7th century language, the same process that Wheeler's it from bit describes in 20th century physics. The Islamic tradition also provides a concept that illuminates the ongoing nature of divine observation. The concept of Qayyum, one of the 99 names of God, describes God as the self-subsisting, the one who maintains all of existence in being at every moment. Nothing exists except through God's continuous sustaining. If God's attention were withdrawn from any part of creation for a single instant, that part would cease to exist. This is not a theological metaphor. It is a cosmological claim. The universe is continuously being observed into existence by the divine consciousness, and the observation never stops and cannot stop, because the cessation of observation would be the cessation of existence. The first observation is also the continuous observation. The Big Bang is not an event that happened once. It is an event that is happening now, sustained, renewed, and actualized at every moment by the awareness that called it into being. The Christian tradition adds a dimension that connects directly to information theory. The Logos, the Word, the informational principle, is identified with God in the prologue to John's Gospel. God is not separate from the information that constitutes reality. God is that information. The divine mind and the mathematical structure of the universe are not two things. They are one thing. This is remarkably close to Tegmark's mathematical universe hypothesis, with one crucial addition. The mathematical structure is not abstract and lifeless. It is conscious. It is experiential. It is alive. The Logos is not dead mathematics. It is living mathematics, mathematics that knows itself, that experiences itself, that creates from itself the physical universe that is its self-expression. The impersonal consciousness position corresponds to Advaita Vedanta, to Dzogchen Buddhism, and to the deepest reaches of Sufi metaphysics. Brahman is not a personal God who decides to create. Brahman is the conscious ground of all existence, and the universe is the spontaneous self-expression of that ground. The Mandukya Upanishad describes Brahman as not conscious of the internal world, not conscious of the external world, not conscious of both, not a mass of consciousness, not conscious, not unconscious, a state that transcends all categories, including the category of consciousness itself. This is not a description of nothing. It is a description of a ground state so fundamental that no concept, including the concept of consciousness, can adequately describe it. It is the turiya, the fourth state that is prior to waking, dreaming, and deep sleep, and that is the source from which all three arise. Ibn Arabi's Wahdat al-Wujud makes the same claim in Islamic language. There is only one being, and that being is God. But God, in Ibn Arabi's framework, is not a personal deity sitting outside creation. God is being itself, the existence that is the ground of all existences, the awareness that is the ground of all awareness. The universe is not something God made. The universe is something God is. Each moment of physical reality is a breath of the divine, a tajalli, a self-disclosure, an act of consciousness, becoming aware of itself through the forms it takes. The first observer, in Ibn Arabi's framework, is being itself, aware of itself, disclosing itself, in an eternal process that has no beginning because it is not in time. It is the ground of time. The Dzogchen tradition describes Rigpa, the natural state of pure awareness, as the ground from which samsara and nirvana both arise. Rigpa does not choose to create the universe. It does not intend to create the universe. The universe arises spontaneously from Rigpa the way reflections arise spontaneously from a mirror. The mirror does not decide to produce reflections. Its nature is to reflect, and consciousness does not decide to produce a universe. Its nature is to manifest. The Big Bang, in this framework, is not a decision, or a command, or a measurement. It is the natural, spontaneous, effortless self-expression of awareness, the way consciousness is when it is not being shaped by the constructions of a particular mind in a particular body. Rumi expressed this with the poetic precision that is his hallmark. You are not a drop in the ocean. You are the entire ocean in a drop. This is not inspirational rhetoric. It is an ontological statement about the nature of consciousness. The ocean is the undivided awareness from which all things arise. The drop is the individual self, apparently separated, apparently finite, apparently bounded, but the drop contains the ocean. The individual consciousness contains the universal consciousness. Not a fragment of it, not a reflection of it. The whole of it compressed, localized, experienced through a particular body and a particular brain, but never actually reduced. The first observer is in you, not as a memory of some distant cosmic event, but as the living awareness that is reading these words right now. The ocean has not been divided, it has been concentrated, and the concentration is you. Wheeler's participatory universe corresponds to the most paradoxical and most sophisticated expressions in several traditions simultaneously. The Buddhist concept of dependent origination, in which the universe and the observer co-arise, with neither one prior, is the closest philosophical match to Wheeler's self-excited circuit. The Kabbalistic concept of Tzimtzum, in which God contracts to create space for the universe, and the universe expands to fill the space that God vacated, describes a mutual process of creation in which the creator and the creation define each other, and the Sufi concept of the mirror of God, in which God creates the universe in order to see himself, and the universe's observation of God is simultaneously God's observation of himself, is a precise description of the self-excited circuit in mystical language. The eye at the end of Wheeler's U is looking at the Big Bang, but the Big Bang is looking back, and what it sees is itself. So who is the first observer? We must resist the temptation to claim more certainty than the evidence warrants. The measurement problem is real, but it has multiple proposed solutions, and none has been definitively confirmed. The panpsychist argument is logically rigorous, but it remains a philosophical position, not an empirical finding. The contemplative traditions are remarkably consistent, but consistency does not equal proof. And the fine-tuning of the universe, while genuinely puzzling, may have explanations that do not require consciousness at the foundation. What we can say is that the confident materialist dismissal of consciousness as a fundamental feature of reality is no longer tenable. The measurement problem, the hard problem, the information-theoretic structure of physics, the failures of emergence to explain subjective experience, and the convergent testimony of every introspective tradition in human history have collectively undermined the assumption that consciousness is a late, accidental, unimportant byproduct of an unconscious universe. Whether consciousness is literally fundamental, or whether the truth is something more subtle that our current categories cannot capture, is a question for future science, future philosophy, and future contemplative investigation to resolve. After everything we have examined, the quantum mechanics of the measurement problem, the informational foundation of physical reality, the panpsychist argument for fundamental consciousness, the cosmological implications of integrated information theory, the participatory universe, and the testimony of every major contemplative tradition on Earth, the most honest answer is, the question may be its own answer. The first observer is not a being who existed before the universe and then created it. The first observer is not a human who appeared after the universe and then looked back. The first observer is the universe itself, the self-aware, self-actualizing, self-observing process that brings itself into existence through its own intrinsic capacity for awareness. Consciousness does not observe the universe from outside. Consciousness is the universe, observing itself from inside. And the act of observation is not a single event that happened at the Big Bang. It is a continuous process, an eternal, ongoing, never-finished act of self-awareness that constitutes the very fabric of physical reality. Every quantum measurement is a moment in this process. Every collapse of a superposition is an act of the universe becoming aware of one more aspect of itself. Every conscious being, every human, every animal, every organism with any degree of integrated information is a point at which the universe's self-awareness becomes concentrated, intensified, and capable of reflecting on its own nature. You are not a spectator watching the universe from outside. You are the universe, looking at itself through the particular window of your body and your brain. And the light that enters through your window is the same light that entered through every window that has ever existed, the same consciousness, the same awareness, the same first observer seeing itself for the first time and for the 10 trillionth time simultaneously. The physicist Arthur Eddington, one of the great minds of 20th century science, wrote, "The stuff of the world is mind stuff." He meant this literally. The substance of the universe is not matter. It is not energy. It is not information, although information is closer. The substance of the universe is awareness, the capacity for experience, the intrinsic quality of knowing, the light that illuminates everything and that is not itself illuminated by anything else, because it is the source of all illumination. The Quran says, "Allah is the light of the heavens and the earth." The Upanishads say, "Brahman is consciousness, Brahman is bliss." The Buddha said, "Luminous is this mind, and it is defiled by adventitious defilements." The Gospel of John says, "The light shines in the darkness, and the darkness has not overcome it." They are all describing the same thing. The first observer, the light that was there before the universe began, the awareness that is not created by the brain but that creates through the brain, the consciousness that did not evolve from unconscious matter but that manifests as matter in order to know itself. This is not proof. Science has not proven that consciousness is fundamental. Philosophy has not resolved the hard problem. The contemplative traditions offer testimony, not laboratory data, and the question of the first observer remains, as it has always been, the deepest open question in human thought. But the convergence is real. The physics points toward it. The information theory demands it. The philosophy argues for it. The contemplative traditions describe it. And the question itself, the fact that you can ask who is the first observer, and that the asking is itself an act of observation, An act of the universe becoming aware of the question of its own origin may be the most powerful evidence of all, because the question could not be asked in a universe that was not conscious. The fact that you are asking it proves that the universe is aware, and the fact that the universe is aware that awareness exists, that consciousness is real, that there is something it is like to be you, reading these words, right now is the most fundamental fact in existence. More fundamental than the Big Bang, more fundamental than the laws of physics, more fundamental than space and time and matter and energy. You are the proof that the first observer exists, not because you are the first observer, but because the awareness that is looking through your eyes right now is the same awareness that has been looking since before looking was possible. It is the awareness that will be looking after the last star goes dark. It is the awareness that does not begin and does not end, because it is not in time. It is the ground of time. It is the ground of space. It is the ground of everything. And this awareness, this first, last, and only observer, is what every tradition in every century has been pointing toward when it speaks of the divine. Not a bearded figure on a throne. Not a cosmic engineer tinkering with physical constants. Not a judge tallying sins and virtues, but the awareness that is the ground of all existence, the light that illuminates all things, the consciousness that is not a product of the universe but the condition for its possibility. The mystics tasted it in their deepest contemplation. The physicists are tracing its signature in their equations, and you are experiencing it right now in the simple, undeniable fact that you are aware. The first observer is not someone who looked at the universe from outside. The first observer is the universe looking at itself, and it is still looking, right now, through you.